Hi everyone, today we are looking at question 16 of 2018 HSC mathematics paper. The question goes like that. A sector with radius 10 centimeter and angle theta is used to form the curved surface of a cone with base radius x centimeter as shown in the diagram. So basically what they are trying to say is that we have this sector which is basically a full circle with that smaller circle cut off from that. So we cut this along this line. Okay? So you get a full circle and cut it along this line to get this sector. The radius of the circle was 10 centimeters. Then what we do, we bend this over so that this radius overlaps with this radius, and we end up with a cone like this. And obviously this radius of 10 centimeter will be this oblique height of your cone, which is 10 centimeters. The volume of a cone of radius r and height h is given by this. V is equal to 1/3 pi r squared h. Then in part 1 they are asking us show that the volume V cubic centimeter of the cone described above is given by V is equal to 1/3 pi x squared times by square root of 100 minus x squared. Then from that, in part 2, they are asking us to show that the derivative of volume with respect to x is given by this expression. And finally, we are asked to find the exact value of theta for which the volume is a maximum. So what should be the value of this theta? So we have a cone which is of the maximum possible volume. Okay, for part A, we are going to show that the volume is equal to this amount. If we look at this cone and we call the radius of the base as x and the vertical height as h, then the solution for part I will be as follows. In this right angle triangle, I can use Pythagoras to write h squared plus x squared is equal to 10 squared. Then h squared plus x squared is equal to 100, and h squared is 100 minus x squared. And h is equal to square root of 100 minus x squared. But why I did that and how I know that is the steps I need to take comes from the question. As you can see in the question and the answer they are expecting from us, they have given the volume in terms of x. But if I want to give the volume here, the volume using this formula will be 1/3 pi times r, radius of the base, which is in this case is x squared, times by to end up with v is equal to 1/3 pi x squared h. Okay, x is fine, but I don't want to have h in my equation because here it's given only in terms of x. So that is how we know that we need to express height in terms of x. Okay, once we've done that, in this formula which I just got, v is equal to 1/3 pi x squared h, I'm going to replace this h with this expression, resulting in 1/3 pi x squared square root of 100 minus x squared, which is basically the answer that we are required to give for part I. For part 2, we are going to find the derivative of volume with respect to x, dv to dx. That's what they are asking us to find. Using v is equal to 1/3 pi x squared times square root of 100 minus x squared. Okay, here obviously I need to use the product rule because v is the product of two functions, this 1/3 pi x squared and this square root of 100 minus x squared. If I use the product rule, which says if v is equal to uv, then or y is equal to uv, then y dash is equal to u dash v plus uv dash. If I apply this rule, then I'm going to find my derivative. However, there are two v's here that you shouldn't confuse. This v is for the volume, but this v here is one of the products which are making up my original function. In this case, for example, I can take this as my u and this as my v. So v is equal to the product of u and v. I call that u and I call that v. Okay, using the product rule, so we have u, as we said, is 1/3 pi x squared. Then I need to find u dash, which is the derivative of that, becomes 1/3 times pi times 2x. So u dash becomes 2/3 pi x. And v is square root of 100 minus x squared. I can write this as 100 minus x squared to the power of half and then use the chain rule to find my derivative. So that means v dash is equal to, this power comes to the right and multiplied by the expression, then the power is decreased by 1, half take away 1 is minus half, then you times by the derivative of the expression inside the bracket, which is minus 2x. Okay, so if we simplify that, v dash is equal to this half and 2 cancels out, but you got minus still, so it becomes minus x times bracket 100 minus x squared to minus half, and that means minus x over square root of 100 minus x squared. Why? Because a power of half means square root, and a negative power means I need to write it in the denominator. So it goes into the denominator and becomes the square root. Okay, now applying this rule, y dash is equal to u dash v plus uv dash. Y dash is equal to u dash v plus uv dash. Y dash will be, my u dash is 2 pi on 3x times v, which is square root of 100 minus x squared, plus u, which is 1/3 of pi x squared times by v dash, which is minus x over square root of 100 minus x squared. Okay, now we simplify that to try to make it in the form that they are given to us. So v dash, here I should have used v dash because we are basically differentiating that. V dash is equal to 2 pi x 3, and I can write also this at the top, plus minus pi x squared times x cubed, so minus pi x cubed, and that 3 goes in the denominator multiplied by 100 minus x squared. Now all I have to do is take a common denominator, so that would be my common denominator because already I've got 3 there. So 3 times 100 minus x squared. Okay, for this one, because this factor is not in its denominator, I got to times the numerator also by this. So it becomes 2 pi x times 100 minus x squared times by square root of 100 minus x squared. For this one, I already got the same denominator, then I don't need to do anything. I write the numerator just the way it is. Okay, this simplifies to v dash is equal to 2 pi x, and this is square root times this is square root, just we lose the square root, minus pi x cubed over 3 square root of 100 minus x squared. Okay, they wanted us to show that the derivative is pi x, so that's what we need to come up with. Pi x 200 minus 3x squared divided by 3 times square root of 100 minus x squared. So we got to try to put this in that form. So because pi x has been factorized, then we can factorize for pi x in that one. So it becomes v dash is equal to, if I take out pi x, I've got 2 times this bracket, so 2 times 100 minus x squared, then minus pi x has been taken out, so pi goes and one of the x's is gone. I end up with x squared over 3 square root of 100 minus x squared. And this becomes 200 minus 2x squared minus another x squared. So I end up with 3x squared. So, and 2 times 100 is 200. So I end up with the answer that they have asked to come up. So pi x, that's 200. Then minus 2x squared minus another x squared becomes minus 3x. Okay? So that is the answer to part 2. For part 3, they are asking us to find the value of theta, to come up with the value of theta, which will give the maximum value. You know that to find the maximum value of any function, we need to differentiate it, put it equal to 0, and we get a stationary point that could be a minimum or a maximum. Okay, so because already I've got dv over dx, so dv over dx is equal to pi x times 200 minus 3x squared divided by 3 times square root of 100 minus x squared. We need to put the derivative equal to 0 so we can find the possible maximum point. Okay, so this is equal to 0 and the value of dv over dx is just that. Okay, for a fraction to be 0, only the numerator needs to be 0. So we put pi x times 200 minus 3x squared equal to 0. Okay, from that, when two products, two terms times together become 0, one of them or both of them needs to be 0. So either pi x equal to 0 or 200 minus 3x squared equal to 0. From the first one, you get x equal to 0. From the second one, you get 200 is equal to 3x squared. Divide both sides by 3, you get x squared is equal to 200 over 3. And x is plus minus square root of 200 on 3. Okay, x equal to 0 has no physical meaning because if x is equal to 0, so we have a cone with a base radius of 0. So has no physical meaning. Alright, so there will be no cone. Okay, for x equal to minus square root of 200 on 3 also is not acceptable because it is a length. And length cannot be negative. As x is length, is a length and cannot be negative. So the only answer left is x is equal to 200 square root of 200 over 3. You can simplify that a bit, so that becomes 100 times 2 over 3. And the square root of 100 is just 10. So we can take it out. And then the square root of 3 is here still. To rationalize it, you can also times the numerator and the denominator by root 3. That will give you 10 root 2 times root 3 is root 6, and that becomes just 3. Okay, that is the value of x. We need, however, to show that for this value of x, we have the maximum possible value for v. For this to happen, I got to look at the behavior of v or its derivative, to be more accurate. Behavior of the derivative of v with respect to x. And we know that when x is that much, that derivative is 0. If I can show that for values of x less than that, my derivative is positive, that would mean that v over the function of v, the volume itself, actually is increased. So a positive derivative means an increasing function. So that means your v is increasing. At that value is 0, so it means you have a stationary point. And for values of x beyond this, it must be decreasing. So we have a function which peaks at 10 root 6 on 3. Okay, so in other words, for values of x less than that, the derivative must be positive. For values of x larger than that, the derivative must be negative. Okay, we can show that by simple reasoning. What we have for dv over dx is that. That's your dv over dx. The way we can reason is that you can go to the second derivative and all that, but also probably it's easier just to write a couple of sentences. So we say that as x is positive because it's a length, it is a length, then 100 minus x squared square rooted also is positive. So that means that the sign of dv on dx depends on the sign of 200 minus 3x squared. Okay. The sign of the derivative solely depends on the sign of this bracket, because everything else is positive. So as x increases beyond 10 root 6 on 3, 200 minus 3x squared will be negative. Okay, because here is 0, and when I'm increasing the value of x, I'm actually decreasing the value of that, and it goes under 0, so it becomes negative. And as x increases while it is less than 10 root 6 on 3, the value of 200 minus 3x squared will be positive. It will be a positive. Okay, so because as long as x is less than that, the whole value will be larger. So the smaller the x, the larger this whole value. So when I'm talking about values of x which is less than 10 root 6 on 3, then I've got a positive value. Okay, when I'm going beyond that, this value as a whole decreases, so making it less than 0, which is okay. So this means that we have a maximum value when x is equal to this. So when x is equal to square root of 203, we have a maximum value for volume. Or basically, remember, we simplified that to 10 root 6 on 3. Okay, but however, they are not asking us to give the value of x, they are asking us to give the value of theta. So if we go back to the sector we had, that angle was theta, that was 10 centimeters, and x was the radius of your cone. So that was x, and that was 10. Okay. Now we want to find the value of theta. Okay. What we need to notice is this base that I have here is the same as the length of this arc. Okay, the length the length of this arc will be exactly equal to the circumference of this circle. So what does it mean? I can say 2 pi x, which is this circumference, is equal to the length of this arc. And you know that the length of arc is equal to length of any arc is r theta, but theta has to be in terms of radians. So my radius here is 10, so 10 times by theta, which I don't know yet. But the x value was that much. So 2 pi times 10 root 6 on 3 is equal to 10 theta. I can divide both sides by 10, that 10 and that 10 will go away and end up with 2 pi times root 6 on 3 is equal to theta, and that's basically my answer. So theta is equal to 2 pi times root 6 over 3. That is the value of theta that will result in maximum volume for the cone. Thank you.